Hello everyone, welcome to this course on From Zero to Hero in Trigonometry. So in this lesson, we are going to do some problem solving. We'll start off with very easy questions, then we'll move on to difficult ones later on. So let's see first question. First question is 2 tan 30 degrees divided by 1 plus tan squared 30 degrees. The options are sine 60 degrees, cos 60 degrees, tan 60 degrees, and sine 30 degrees. So you can just pause this video for a few minutes, try this question on your own, and then come back to this video. Okay. Meanwhile, I'll try to solve this question. So we have 2 tan 30 degree divided by 1 plus tan square 30 degree. So 30 degree, and when you look at the options, you have either 30 degree or 60 degree. So it is easily understood that these are standard angles, and you know these values straight away right from your memory. You can just substitute. So we have 2 times tan 30 degree is going to be 1 by root 3 divided by 1 plus 1 by root 3 the whole square. So this is going to be 2 divided by root 3 divided by 1 plus 1 by 3. So this is 2 by root 3. Denominator we have 4 by 3. So that is going to become 3 by 4. So this becomes root 3 divided by 2, which is sine of 60 degrees. Which is sine of 60 degrees. Of course, there is a pattern. This 30 degree has doubled and it has become the sine of 60 degree. In fact, this is another identity that you learn in higher class. In the next subsequent lessons. For the time we have done it for a standard angle, and later lessons you will learn that 2 tan theta divided by 1 plus tan square theta is going to be sine of 2 times theta. All right. So we have just verified that for a very standard angle, that is 30 degrees. All right. So let's see another question. Question is 1 minus tan square 45 degrees divided by 1 plus tan square 45 degrees. The options are tan 90 degree, 1, sine 45 degrees, and 0. Now let's see that we have 1 minus tan square. So these are standard values you can directly substitute. So we have 1 minus 1 square divided by 1 plus 1 square, which is coming out as 0. So 0 is the right answer. Now my next question is sine of a plus b equal to sine of a plus sine of b? Is this true? Is this true? Is this true in general? Just think for a minute and tell me. No, it is not, right? You can just take a counter example and verify that this is false. Okay. In fact, you would have seen other things, like for example, when you take a plus b whole squared, this is not equal to a squared plus b squared in general. Okay. What I mean to say is that suppose there is a black box which squares the numbers. Okay, which squares the numbers. For example, if you give a, this gives me a square. Similarly, if I give b, this gives me b square. Now my point is, if I feed a plus b to this box, okay, meaning the sum of inputs, these two inputs to the box, it won't give me sum of these two inputs. It is going to give me a plus b whole squared, which is not equal to a square plus b square in general. Okay. Similarly, if you feed a plus b to the black box that is giving you the values of sine, it won't be equal to sine of a plus sine of b. Okay. You can verify that. See, to disprove this statement, you just need to take a counter example. So, for example, you take a is equal to 30 degrees, b is equal to 30 degrees, and in the LHS it is going to be sine 60 degrees, which is root 3 by 2. On the RHS it is going to be 1 by 2 plus 1 by 2, which is a false statement. Okay. Of course, you can't take an example in which this is true and claim that the statement is true for all values of a and b. You can't do that. For example, if you take b is equal to 0 degrees, a is equal to 30 degrees, the statement is going to be true, right? But just by taking a simple specific example, you can't claim that the statement is true for all values of a and b. But on the other way around, like if you take a counter example, you can easily disprove a statement. So this is not true in general, right? Let's see another question. Sine 3a, if sine 3a is equal to cos of a minus 26 degrees and 3a is given to be an acute angle. 3a is given to be an acute angle. What is the value of a? Again, pause this video for a minute or so and try this question on your own. All right, so let's come back to this question. So we have sine of 3a is equal to cos of a minus 26 degrees. So how do we compare sine and cos? So we have this relationship. We can use this idea that sine theta is nothing but cos of 90 minus theta. Cos of 90 minus theta. Right? Now, what we can do is we can write the sine of 3a as cos of 90 minus 3a equal to cos of a minus 26 degrees. Okay. Now, in the next step, you can write 90 degrees minus 3a equal to a minus 26 degrees. Of course, this is the case since it is given to be an acute angle. In general, when you move on to the next advanced lessons, you'll realize that this is not always the case. As in, when somebody tells you that cos of x is equal to cos of y, it does not necessarily imply x is equal to y. It does not necessarily imply x is equal to y. But the other way around is true. If x is equal to y, you can write cos x is equal to cos y. This is true. But the other way around is not always true. Okay, cos x is equal to cos y does not necessarily imply x is equal to y, that you will see in the upcoming lessons. But for the time being, since we are dealing only with acute angles, you can straight away write that 90 minus 3a is equal to a minus 26. So we have 90 minus 20 plus 26 is equal to 4 times a. So you can solve this. So we have a is equal to 116 whole divided by 4, and that comes out as 25 plus 4, which is 29 degrees. 29 degrees is the answer. Let's see one more question. Question is, if A, B, C are interior angles of a triangle ABC, show that sine of B plus C by 2 is equal to cos A by 2. Now, how do we attack this problem? And by the way, please pause this video and try to solve this on your own. Okay, now I hope that you're back with the answer. So when you see this question, how do you attack this question? You see sine on one side and you see cos on another side, and it is given that A, B, C are angles of a triangle. So in a triangle, you know that if you have A, B, C, we know that A plus B plus C is going to be 180 degrees. Now somehow we have to isolate angle A, because they are talking about A and A by 2 and things like that. So I'm going to isolate A. Of course, B plus C will come out as 180 degrees minus A. Now we don't need B plus C, we need B plus C by 2. So if I take B plus C by 2, this is going to be 90 minus A by 2. Now it's straightforward, right? Now you take sine on both sides, take the sine of this angle on both sides. We have sine of B plus C by 2 will come out as sine of 90 minus A by 2. Again, sine of 90 minus theta is cos theta. So this comes out as cos of A by 2. Okay. So we just saw very simple problems. In the next lesson, we'll show some more advanced problems that may take a little more thinking. All right.